Hi, welcome to Physionic. Today's video is going to be a lengthy one, well, sort of lengthy, to discuss the first of a series of studies looking at how saturated fats and unsaturated fats have an impact in humans on insulin sensitivity. Now, this study that we're going to be going over today actually looks at more than just insulin sensitivity. They look at certain health markers like cholesterol, different types of cholesterol, LDL, HDL, triglycerides, as well as ApoB levels. So we're going to go into that as well. But the main outcome that I'm most interested in for this study was its effect on insulin sensitivity. So it kind of follows a traditional route, and then at the very end they add a little piece of data that is rather, it's just like they throw it in there, and it's confusing, it's interesting, it throws everything on its head, and then they just kind of peace out. They're like, all right, see ya. So I will be interested in your take, if you get to that point, what you think the reason is for the results. I'll leave it at that, but this particular video is going to be in combination with, I've already picked out a few other studies looking at saturated fat and unsaturated fats on insulin sensitivity. Now, I released a series, or I'm in the middle of releasing a series on how saturated fat and unsaturated fat affect our muscle insulin sensitivity. Now I'd like to start to have another series on how it affects our pancreas, which is, of course, the organ that releases insulin, which is it's kind of the other side. So while muscle is the part that accepts the insulin and accepts the blood sugar, the pancreas is the organ that then releases the actual insulin and reacts to the sugar. So I thought that might be an interesting angle to also attach. So I have several different series going on at the same time. I've got one on carbohydrates and their effect on metabolism. I've got this one on fats and their effect on muscle insulin sensitivity, and now I'm going to have one on pancreas and insulin sensitivity, and then I've got a fourth one that I'm actually working on as well. But I'll announce that once we've gotten a little deeper and gotten through some of these studies, because otherwise it gets too muddled. So that out of the way, however, if you're not familiar with who I am, my name is Nicholas Verhoeven. I'm a PhD candidate in molecular medicine, and I thoroughly enjoy going through studies like this in great detail. So that's exactly what we're going to be doing in this long-form video. If you want a more short version, then maybe you just look up the study number that I've got listed for this study, and then you can, usually, not for all videos, but for a lot of them, you'll find a short version that has more graphics and things like that. But rest assured, if you do want the more detailed breakdown, then this is the video to be on. So the question that we're going to be examining here is looking at how does extended consumption of a saturated fat or unsaturated fat diet affect insulin sensitivity and other health markers? Now, by extended consumption, I'm talking about 3 months. If you feel like that's too short of a time, then, well, that's a fair critique. I think I would tend to disagree. I think 3 months is definitely enough, but maybe you disagree, which is perfectly acceptable. Now, this information comes from this study right here, which has a series of it has some kind of conventional results that we found in a lot of the other studies that we've looked at, but there are also some kind of unconventional results. So I'll be really interested in your take. So please comment, let me know your thoughts on this. So the study name is Substituting Dietary Saturated for Monounsaturated Fat Impairs Insulin Sensitivity in Healthy Men and Women, the Conwu study. And remember, just because the title says this does not necessarily mean that is actually the case. The interpretation of the data is up to the reader. And this is actually this is a much older study, and it comes in a highly reputable journal, which we're actually going to be covering. I didn't even plan this, but a lot of studies that I picked out come out of this journal. All right, so to walk you through a little bit on the study design, this is a really simple schematic, but they recruited 162 participants, men and women, as you saw from the title, an average age of 48 years old. And while the spread of these individuals, meaning that the variability between individuals was pretty great in terms of some people being normal weight, other people being overweight, the average was that they were overweight slightly, I think. It was like BMI of 26. And yes, they're using BMI because these aren't athletes or anything like that. The reason I've got here that they're largely healthy is that a few of them had the beginning signs of insulin resistance. So they were maybe pre-diabetic or entering pre-diabetes. So they weren't diabetic, but they were still included. If people were diabetic, they were excluded from the study. So a few of the participants do have mild insulin resistance. If this ends up affecting the results of the study, well, we'll see. Keep in mind, this is 162 participants. So if you, let's say, have 5 of them that are insulin resistant, if you have 2 of them in one group and 3 of them in the other group, that's going to get watered down substantially, and it will show itself in the statistics as well. All right, so we've got these men and women, and they end up being put on a weight maintenance diet with the same proportion of nutrients. So they had 37% fat, 45% carbohydrates, and 15% protein. Now, if you do the math on that, that does not come out to 100%, which is always confusing to me. I always wish that researchers would explain their methodology when it comes to this stuff. It's usually like 2 or 3% off of 100%, but I think what they're doing here is they're just showing you the averages. This is what they were aiming for. So you'll have some people, and I definitely know this, that you'll have some people that'll consume 41% fat, and maybe they'll consume a little bit less carbohydrates when it's all said and done. So, but the overall, what they generally found is that people consumed these numbers, or they'd aimed for these numbers. So they got pretty close. On these weight maintenance diets, then, they were segregated into 2 different groups. So one of the groups was obviously high saturated fat, and I say that a little bit with quotations, a saturated fat group and an unsaturated fat group. So the saturated fat group consumes 17% of these 37% fat as saturated fat. So not like extremely high, right? I've certainly seen studies do a lot more than that, like 20, 25, 30% of their diet as saturated fat. And the unsaturated fat had 25% unsaturated fat. Now, of course, the other proportion, so 17% maybe saturated fat here, that means the rest of it is unsaturated fat because you have to make it up somehow. And in terms of everything else was equal between the 2 groups. So the only difference was the proportion of this fat number being made up of saturated fat or unsaturated fat. And the participants had blood measures that were taken before being put on each diet and then 3 months later, so after 90 days. And so to speak on the statistics real quick, what they did is they did statistics, and I'll be showing you this data, but they did statistics in such a way, so they did 2 different types of statistics. That's what my mouth is doing right now. Number 1 is they compared the pre-diet to 3 months later. So pre versus post. So that's within groups statistics. The other thing that they did was look at the comparison between the 2 diets, of course, the saturated fat versus unsaturated fat, which is known as between groups statistics. All right, so let's begin looking at this data. I can reappear like a wizard through the mist. I've got this really simple schematic here, mainly just to illustrate what we're going to be looking at here. And I realize this is a bunch of numbers, but don't worry, it's not really that complex, and I'm going to walk you through it. So we've got let's start here with serum insulin. Serum insulin is right here. That's what this is. It's just the amount of insulin that's found in the bloodstream. So this is a blood vessel, so it's cut in half so you can see the inside of one of your veins, your arteries, and then you've got insulin floating around in that system. Great. That's serum insulin. That's displayed right here. First phase insulin response is just exactly how it sounds. It's just the initial insulin release from the pancreas, as I mentioned in the introduction. And the next one is plasma glucose, which is right here. So plasma or serum being about the same thing. In this situation, plasma glucose is just blood sugar. That's all it is. You likely know it as blood sugar. Now, the insulin sensitivity index is once this insulin binds to a cell. Usually I use a round cell, but this time I decided to switch things up. We're looking at an endothelial cell here, which is a more square-shaped cell. So when insulin binds the exterior of, and not that we're zooming in like we usually do, but normally we would zoom in and we look at a receptor that's found on the cell, and insulin would then bind that receptor, and then there are these gateways, in a very simple way of talking about it, that open up, and then the glucose then enters the cell. So that is insulin sensitivity, in that if you have fewer insulin molecules that are needed to get the same amount of glucose into the cell, that means, yeah, you're very insulin sensitive. Great. However, so let's say it's one insulin molecule is needed to get one molecule of glucose in. Okay, that's our baseline. Now, if a person is less insulin sensitive, or otherwise said is more insulin resistant, then it might take 2 molecules of insulin to get the same amount of glucose. You see where I'm going with this? It's just it's taking more insulin to get the same amount, or sometimes less, glucose into the cell. And that's what's measured here, insulin sensitivity index. There's a calculation that goes into this, so I can't exactly display it in a picture nearly as well. But just know that that's what insulin sensitivity is. All right, so here what they're doing is they're showing the change. So the big 2 factors that you should be focused on here is to look at the overall change. This is on the saturated fat diet, and this is on the unsaturated fat diet. And I know it says MUFA for monounsaturated, but they also have polyunsaturated. So the saturated fat diet, unsaturated fat diet, and here we're looking at the amount of change. So obviously if it's a minus, it's going down, and if it's a plus, it's going up. And here, or if you don't want to look at the absolute numbers, which is right here, then what you can do is look at the percentages. Also perfectly acceptable. So they find the percentages based off of the absolute change. And now here is the other aspect that you should be looking at is if this number is below 0.05, which is what they set as their baseline, which is a very statistical baseline, I should say, then that means that there is a significant difference. So if we're just looking at this section right here, we're just looking at saturated fat, what are we comparing? Remember, there are 2 statistical methods we mentioned. If you're thinking that we're comparing the baseline, so before they were put on the diets, to after they were put on the diets, you are correct. You are a winner. Because so if this is less than 0.05, then there is a difference between pre-diet versus post-diet or post-nutrition intervention of saturated fat. And the same thing if we just focus on this section. Now, then they have a second statistical method, and the reason why I'm taking this time to explain this is because on the next data we're also going to be looking at it's going to be set up exactly like this. The other statistical method is to look at the difference, the comparison between saturated fat and the unsaturated fat. And here we get the same thing. So same statistical prowess, the baseline and all that stuff. The differences are calculated based on the differences between the 2 diets and the amount of, I suppose they don't show the percentages, but they still show the differences, and we can still see the statistical method. Okay, so hopefully I've done justice to explain that to you. So it's really not complicated. You just need to look at the p-value here, and then you can choose if you want to look at the percentage or if you want to look at the change. And Voila. Okay, so let's look at insulin sensitivity here. So insulin sensitivity with saturated fat seems to decrease. So we've got a 10% decrease in insulin sensitivity, and that is statistically significant if we just look at the pre-diet versus post-diet. Now let's look at monounsaturated fat. Although it looks like there's an increase, let's say by 2.1%. I'll focus on the percentages here. Although there seems to be an increase, technically, statistically, there's no difference. So for the unsaturated fat, there's no improvement or decrement in insulin sensitivity, but in the saturated fat condition, there is a reduction in insulin sensitivity. Now, if we compare the two between one another, we find that technically right here, we are like razor thin on it being significant. So you can choose if you want to believe it. I mean, it's 0.05. I'll bet you if they just added a few more participants to each group, you would find this as statistically significant. So I'm going to go ahead forward as if it is statistically significant. So it's 0.0534. They're adding like way down the line. They have just a little bit that leads to it, quote unquote, not being statistically significant. But let's be real, it is. So, and that's of course up to you. If you think I'm full of it, that's all right. So there is a statistical significant difference between the saturated fat and unsaturated fat conditions. So then looking at serum insulin, so the amount of insulin that's around, again, when we're looking at saturated fat, there seems to be maybe a slight increase, but there isn't really. See, these could be due to any sort of variability. Therefore, we can't say that even though there's a percentage increase, we have to rely on the statistics. We can't just look at these percentages and just say, oh yeah, there's an increase in insulin. No, we have to look at the statistics to verify if this isn't some random chance just increase in insulin as opposed to an actual consistent trend in an increase in insulin across multiple participants. Many of the participants had an increase in insulin. So what we find is no, there's no statistically significant increase in serum insulin. Now, for the unsaturated fat, there is a reduction in insulin, 5.8% reduction, and it is statistically significant. So yes, there's a reduction. Again, here we're looking at razor thin margin when comparing the two, but I would venture to say that there is a difference, so that the unsaturated fat, as we saw, shows a reduction in serum insulin, or the amount of insulin that's found in the bloodstream. Now, the first phase insulin response, some people find that interesting, but there's, I suppose, an increase in the saturated fat condition and no increase, although it shows a 10% increase. This does not reach statistical significance. It's not close enough to then say, oh yeah, well, that's definitely the case. So I would leave this as no, there's no change. And here, again, when we compare between the two, there's no change. Now, plasma glucose, here we're seeing, I mean, this is as no change as you could possibly get, a 0%. So, of course, this is going to be close to 1. This is like as far away from there's going to be a change as you could possibly have. So there's no change in glucose levels with saturated fat. And there's also no change with the unsaturated fat. And there's, of course, no change between the two diets as a result. So what does this kind of tell us, though? Well, we've got two lines of evidence that I'm going to focus on. One of them is that the actual measure of insulin sensitivity, right? We see that there's a decrease in insulin sensitivity of saturated fat, and there's no change in the unsaturated fat. So we don't even need to look at the comparison. We can just look at between those two diets. And then the other thing that's really intriguing here, and remember my definition or how I was explaining insulin sensitivity, is that serum insulin did not change for the saturated fat. However, it did decrease for the unsaturated fat. So this would at least lend credence to the idea that you're getting fewer insulin molecules, and yet you're maintaining plasma glucose levels. So it requires less insulin to control your blood sugar levels with the unsaturated fat diet, which may not necessarily be picked up in the insulin sensitivity index, but it does at least lend credence to this idea that there is a difference between the two. Okay, so that's just an interpretation, but I will say that I think it's a strong interpretation because we have two pieces of evidence that indicate that insulin sensitivity is at the very least not worsened by an unsaturated fat diet, but it is worsened by a saturated fat diet. Now to look at a few more, so again, this is the same exact setup, okay? And here we're looking at other biomedical markers, we're looking at other health markers, and we're going to be returning to this insulin sensitivity thing in the next slide, which is going to be really intriguing. So I'm gonna tease you out there if you're thinking about clicking off already. So cholesterol, so we've got our cholesterol measures, our triglycerides, which are our blood fats, LDL cholesterol, HDL cholesterol, those fall into the cholesterol category. Then we've got different subsections of cholesterol, ApoB, ApoA, etc. But we see that some of them change and then some of them don't change whatsoever. So total cholesterol, we see that saturated fat increased the total cholesterol. And I do have a caveat to this story, so don't let me forget, even though I'm pre-recording this and you can't actually communicate with me. But if I forget, then please leave a comment that there is a caveat to the information I'm about to present to you. But I've got it in my notes here, so hopefully I don't forget. All right, so for the time being, cholesterol increased with the saturated fat condition. Again, looking at the p-value, and again, here we see a decrease with the unsaturated fat, and again, we look at the p-value. Yes, it is different, and the comparison, they're both going the opposite direction, so it'd be really shocking if you didn't find a difference between the two, and sure enough, there's definitely a difference between the two. So cholesterol is increased, total cholesterol is increased by saturated fat diet, it's decreased by an unsaturated fat diet, leading to an overall change. Now, triglycerides, blood fats, are decreased by a saturated fat diet and also decreased with an unsaturated fat diet. So, of course, you're not going to have any difference between the two. The only time you'd see a real difference between the two is if one had such a strong decrease and the other one just had a mild decrease, that there's enough of a difference between those two. Now, looking at LDL cholesterol, again, we see an increase in LDL cholesterol, or low-density lipoprotein cholesterol, and we see a decrease with the unsaturated fat. So, of course, there's a difference between the two. HDL, there does not seem to be a difference across conditions. And I guess you can also look at ApoB and ApoA, which are subfractions of LDL cholesterol. So we've got our LDL cholesterol, and then they've got these sections in them that allow them to bind to particular receptors on, for example, like the liver. And that's what these are, so ApoB and ApoA. And we find that there is no statistical difference or no statistical change in the saturated fat condition, but there's a reduction in the unsaturated fat condition, leading to an overall change. And lipoprotein A, or LPA, there is a increase with the unsaturated fat condition, which overall leads to a change. Okay, so having said all that, I would like to add the caveat that I mentioned earlier. So another thing that they did with this study that I didn't mention is that they had subgroups that supplemented with omega-3 fatty acids. Omega-3 fatty acids from fish oil, so docosahexaenoic acid and icosapentaenoic acid. So those fatty acids were then supplemented in a pill form. I think they took them like 3 times a day, while the other group consumed a placebo, which consisted of not water, but consisted of olive oil. So technically they're also getting some form of unsaturated fat, just not necessarily focused on the 2 omega-3s that I mentioned. So this is the caveat, and this is a bit confusing, and I'd love your take on how to interpret this potentially. I have some initial brewing thoughts, but I don't want to put them on recording yet until I have more proof of my overall ideas. So only those supplementing with omega-3 fatty acids experienced an increase in cholesterol. So let me finish reading this. And those in the unsaturated fat condition that did not supplement were the only ones with a reduction in LDL. So no change in LDL in those that supplemented with omega-3s. And triglyceride reductions were only seen in those supplementing with omega-3s. Kind of odd, kind of just like this sub-analysis that they did. I like it, but this is one of the problems that I have is that they don't actually show any data for this. They just kind of report, they just say it in the text, but they don't actually show any data. So that's definitely a critique on mine, because I would love to actually see it so I could see if there are any problems with their statistics or their the math that they're doing, or how many people are in each group, things like that. That would be nice to know. And also kind of, if going back to our insulin sensitivity aspect, that, a few of the individuals had mild insulin resistance, so they were maybe pre-diabetic. Maybe you had more people in one group taking omega-3s or not taking omega-3s that could skew the results, but whatever. So what they're saying here is that those supplementing with omega-3 fatty acids in the saturated fat condition saw an increase in cholesterol. So when they were supplementing with omega-3s and they were consuming saturated fat, they saw an increase in their total cholesterol. And those in the unsaturated fat condition that did not supplement were the only ones with the reduction in LDL cholesterol right here. So this is driven. So you have one population of people that are not supplementing with omega-3s, they're supplementing with the placebo. And then you have another, so you have one group that is supplementing with the omega-3s. You have another group that's not supplementing with the omega-3s. So let's focus on, let's say the unsaturated fat condition. So the unsaturated fat condition had an overall reduction in LDL cholesterol. So that means that the ones that did not supplement were the only ones that saw a reduced LDL cholesterol. So the overall effect is that, so if they do statistics, they have to do it on both groups. The overall effect is a reduced LDL cholesterol. However, you have this subgroup that does not see a change. So if they do statistics just on this group, they would not see a change in LDL cholesterol. So just to explain how that actually works in terms of looking at these samples. Okay, so that's an added complexity to this that I found interesting. I'm not going to spend a whole lot of time trying to think of potential explanations at this point, but it is something that I should probably look into, because it adds potential flavor, adds a spice to our interpretations, which may end up being slightly changed later on as we go through some other studies as we investigate this. So just to throw that out there, again, they don't actually show any data for this. They just say it. So I like to see data before I actually believe anything, but still. Okay, so then the final piece of data is to look at this, which I think is really, really cool. I thought that this was a good idea. So remember how, let's go back here. Remember how the overall amount of fat consumed was 37% of total fat consumed, and then it was mostly made up of saturated, or had higher amounts of saturated fat versus higher amounts of unsaturated fat. Well, obviously it's not like every person is hitting 37% every single day perfectly. That's just that's the median amount. So that's kind of that's the middle amount. So you have some people that consume over that, let's say 41% or 40%, and other people that were consuming, let's say 35% or 31% fat. And so then what the researchers do is they separate out those two groups on either side of 37%, a la over 37% or under 37%. And they reanalyzed the insulin sensitivity index. So the amount of change, so an improvement in insulin sensitivity or a decrease in insulin sensitivity, okay? And what they show here is that there is an effect of the total fat, or that's one interpretation. So if it's, let's do the under 37%. So if these individuals were consuming under 37% of total fat, then the white are the unsaturated fat, black are the saturated fat, because I just realized it doesn't show that. So the white here shows that exactly what we saw in the data that we looked at when we looked here. Insulin sensitivity is I suppose technically unchanged, but it's in the positive direction. So this is in the positive direction. Remember, this is not looking at everyone, so the numbers are going to be different between this and this because they're only looking at the less than 37% total intake. Hopefully I'm doing justice explaining this. So there is a technical improvement in insulin sensitivity. There's a statistical difference between the two diets, but I don't know if there's a difference between this and the 0, which is the baseline. So I'm not going to assume it. I'm just going to say that there's at least no negativity that affects to insulin sensitivity with unsaturated fat if you consume under 37% of your total intake as fat. However, the saturated fat followed the same trend we saw earlier, that you saw decreases in insulin sensitivity, and there was a statistical difference between those two, so unsaturated versus saturated. That all follows the same data that we already looked at, maybe to different proportions, but still follows the same data. Now looking at those that consumed over 37% total fat, what we find is that, again, we can't, based off of this data, we can't say that the unsaturated fat suddenly now has worse insulin sensitivity because like the bar sure looks under. Yes, I see that, but they didn't run statistics, so we can't actually know. So usually you have like an error bar that tells you, well, maybe the result is actually more on the positive side. But here they don't have any error bars, so it's hard to tell. They didn't run statistics. But what we can tell is that suddenly the difference between the saturated fat and unsaturated fat suddenly disappears, which is really cool, which is a really cool phenomenon. So that kind of, then the question is, well, what's happening here? And I'd like to maybe throw that question out to you as well. I'm going to throw a few possibilities right now. So the researchers mention that this might be because those individuals, so these individuals right here, had a proportional increase in both fats. So not only did they consume more saturated fat, they also saw a proportional increase. They start consuming more unsaturated fat as well, and therefore you don't see this difference between the two diets. If you buy it or not, that's completely up to you. This is just speculation on their part. I don't know if I necessarily buy it yet, although we have seen data where unsaturated fats or a proportional increase in unsaturated fats to saturated fats does seem to, in certain studies, have positive effects. But, I'm not sold on that at all. Not yet, at least. So I think what could also be happening is that there's an overall fat effect. So while the differences between unsaturated and saturated fat are present only when you're consuming lower amounts of fat. I mean, under, let's say 35% is still it's a good amount of fat, but let's say on the lower ends, which means that you're consuming more carbohydrates, right? So there may be some sort of crosstalk between higher amounts of carbohydrates, then you're consuming lower amounts of fat, then you need to focus more on those unsaturated fats. But on the other hand, it's also possible that if you consume a lot more fats overall and you lower your carbohydrate intake, that then suddenly it may not matter as much, the type of fat that you're consuming. Again, let me make myself big real quick. I'm telling you, this is speculation on my part. I am not saying this is definitive proof by any means. I'm just throwing ideas out there as to why this might be the case. And that's why I would love for you to throw out some ideas of your own, because I don't know the answer, but hopefully we can find some sort of answer. And I wish that they had done they have this like little paragraph on this, and then the last sentence is an explanation, and it's literally just like, well, there's a proportional increase in unsaturated and saturated fats. Okay, bye. And then it's just like they just drop it and they're like, all right, we're out of here. Just weird, but whatever. Definitely something we'll be looking more into in the future. I have looked at a lot of ketogenic diet studies, and I've looked at a lot of low carb studies. I haven't focused as much on the insulin sensitivity aspect as much as the cholesterol aspect, triglyceride aspect, and all that stuff. So this might be something that I may need to look into, but the list ever increases, as you know, if you've been following Physionic for a while. All right, so just wanted to throw that out there. The conclusions are going to be a little bit shaky. I'm basing the conclusions off of the main effects, mainly because I didn't see any data for the omega-3 effect that they mentioned. So keep that in mind. This data indicates that, this study indicates that consuming a diet with higher saturated fat reduces insulin sensitivity, increases cholesterol. There was a caveat to that, remember. The same diet with higher unsaturated fat does not affect insulin sensitivity, reduces cholesterol, and like the saturated fat, so both unsaturated and such saturated fat decrease triglyceride levels, which is blood fats. So some of these effects are changed based on if you're supplementing with omega-3 fats or not, which was one of the caveats that we talked about. So in terms of insulin sensitivity, there's also a potential factor in total fat, which is my speculation. That is not what the researchers are necessarily saying, but it's something that I threw out there. This opinion could certainly change, showing that this difference in insulin sensitivity between the fats is lost at higher fat intakes. The reason is truly, however, unknown. So, that all said, I realize that this only offers some answers, and truly the main effects, so the unsaturated fat, saturated fat effects on insulin sensitivity and cholesterol, we've seen that over and over and over again as I was going through my ketogenic diet series or my low carb series. So that part, the part that's actually confusing is the addition of omega-3s because it doesn't fit into the overall narrative, so it is something that I need to look into. But the overall effects that I just reported in the conclusion, those I've seen in at least 12 other studies. We're going to, this is just kind of the first study of many looking at how these unsaturated and saturated fat switches are going to affect insulin sensitivity. So we're going to get more information on all of that going forward. Okay, so I realized that I offered you some questions and didn't offer answers, but on the other hand, it does kind of offer some answers. If you believe just this study, which is one study of several we'll be going over, then typically you would want to aim for more unsaturated fats, kind of regardless. You kind of want to consume more unsaturated fats. So with that, I'll leave you with that, and it was a pleasure as always, and I'll catch you in the next one. Have a good one, guys. Bye.